Hello and welcome to Honors Function. In this last lecture about exponential and logarithm, we're going to be covering two common techniques used in reference to exponential and logarithm. One is how to solve inequality involving exponential and logarithm, and the other technique is the change of base technique. Let's begin with inequalities. Let me first remind you of the definition of an increasing and decreasing function. Let's look at the first graph right here. You have two inputs, A and B, and A is smaller than B. The function is increasing, and if you look at the order of the output, they are in the same order as the input. F of B is greater than F of A, B is greater than A. This is a definition of an increasing function. Order in the input is preserved in the output. And actually it's a definition. A definition is always if and only if. Okay? On the other hand, a decreasing function, you can see right here that you still have A smaller than B, but now F of A is above F of E. Okay? So by definition, a decreasing function will reverse the order from input to output. These are the definition of increasing and decreasing function. Now let's look at the exponential and logarithmic function in base E. These two functions are increasing. Let's apply the definition of increasing to these two functions. So in the first one we have if A is smaller than B, then e to the A is smaller than e to the B. For the second one, for the log, if A is smaller than B, then ln A is smaller than ln B. These are the two properties I will use to solve inequality involving exponential or logarithm. Let's go over some examples right now. So here we go. Let's look at the first property. 3 times ln x minus 1 is smaller than 1. So of course we're going to clean up everything around ln x. So this is equivalent to ln x is smaller than, so 1 plus 1, 2, 2 divided by 3, 2/3. Okay, and then what? And then right here, this is an inequality in log. How am I going to solve it? I'm going to apply on both sides of the inequality the exponential function. And I can do that because exponential is increasing. Now, if I were to do what, Miss Roshan does, I would say you exponentiate both sides. So I've lost my inequality. So basically you could say, hey, you do that right here. Okay. So what's on the left? X. What's on the right? Smaller than e to the 2/3. That's it. Okay. So the solution is negative infinity e to the 2/3 parenthesis. That's it. Okay. Please do number 2. Let me do number 3. Alright, so this one seems a little bit more complicated. Hey, it is really not that complicated, okay? So the first thing you're going to do, of course, is divide by 3.5. So you have 1 minus 1.2 to the x over, what is 1 minus 1.2? Is negative 0.2, right? Smaller than 28 over 3.5. So this is 28 divided by 7/2, right? 3.5. So it's 28 times 2 over 7, simplified by 8, so it is 8, 4, 1, so it is 8 right here. So now what? Now you multiply by negative 0.02. Be careful, it's negative, so you have to flip the sign. 1 minus 1.2 to the x is greater than or equal to 8 times negative 0.02. Negative 0.02 is negative 1/5, so this is negative 8 over 5. So now you subtract 1, negative 1.2 to the x, above negative 8/5 minus 1, which is negative 13/5. You multiply by negative 1 and you flip the inequality. 1.2 to the x smaller than 13/5. And now what do? You apply ln on both sides, right? You apply ln on both sides, and you have now this x is going to go out right here, and so you have, so x times ln of 1.2 is smaller than ln of 13.5. And here I'm going to divide by ln of 1.2. Guys, be very, very careful with that step right here. You're dividing both sides here. I'll write it. Normally I don't write it, but this time I'm going to write it. You're dividing both sides of an inequality by a quantity. You got to make sure you know the sign of this quantity. ln of 1.2 is positive, right? Why? Because 1.2 is above 1, right? If you take any x smaller than 1, the outputs are negative. For any x above 1, the outputs are positive. So you don't have to switch the inequality. And so the answer is x smaller than or equal to ln of 13 over 5 divided by ln of 1.2. Right here. Okay? All right. You do the next example. Let's move on to the second part of these notes. So the second part of the note is about the change of base. What does it mean, the change of base? First of all, in math, we only use one base, okay? We want a base e. That's the only base we use for exponential and for logarithm, okay? Base e. So what do you do if you're given another base than e? You're going to rewrite it in base e. But then how do you do that? So let me show you. It's very easy. You have to remember the formula. It's a very important formula. Anything, let's call it delta if you want to, anything is equal to e to the power of ln of that thing right here. Okay, it's one of the three fundamental formula relating log and exponential, this one. Okay, and that's exactly what I'm going to apply right here. So if I'm given a to the x, I can rewrite it as e to the ln of a to the x, right? So far so good. Okay, so now what do you do? Well, hey, look at this, ln of a to the x, you take the x out, and so it's just going to be e to the power of x times ln a. Done. That's it. Look, you're done, you finished. I told you it's very easy. What do you have on the left? An exponential in base a. What do you have on the right? An exponential in base e. Now, of course, you will not have the equality. That wouldn't make sense, right? If a is different than e, that wouldn't make sense. But you do have the equality if you multiply the power by ln of that base right there. Okay? That's the first relation. Very, very simple. Let's go over the second one right now. For the second relation, we're going to be using the same trick. Here, let me tell you what I want to do. I want to take a log base b of x, and I want to write that in ln, okay? But ln of what? How do I do that, okay? So for this, to prove this, I'm going to use another identity. I'm going to use that x is the same as a to the power of log base a of x, right? That's another one of the identity. You remember that? And then what do? I will apply log base b on both sides, right here, and log base b right here. So what do you have? You have log base b of x equals log base b of a to the power of log base a of x, right? Okay, but now this is an exponent, and the exponent can go out. So this is the same thing as log base a of x times log base b of a. Log base b of a. Now divide both sides by the log base b of a, and you have log base b of x divided by log base b of a equals log base a of x. What do you have on the right? A log base a. What do you have on the left? A log base b, and only b. This is a change of base for logs. I've written a log base a into a log base b. Now, of course, the base we'll normally choose is e, and so we would have log base a of x equals ln x divided by ln a. Okay? This is how we would normally write it. Let's practice some examples now. All right, look at that. Number 6. Show the following formula. So what do I see when I look at this equality? It's an equality of two logs, but they don't have the same base, right? So I'm thinking, hey, change of base formula. So log base 1 over a of x, and I want to write that in log base a. So let me apply my change of base. And I know I have a log base a at the top, and I have a log base a at the bottom, right here, okay? Log base a of what? At the top is x, at the bottom is the base, Okay, 1 over a right here. All right, so what's the log base a of 1 over a? That's one of the formula. 1 over a is a to the negative 1. Log base a of a to the negative 1 is negative 1. So it's a log base a of x over negative 1. So it is the opposite of the log base a of x. That's it. Very, very simple. I'm going to let you do number 7. Number 7 is actually an important formula. If you remember it, it's great. It's when you change the base and the input. You can change the base in the input, but you have to have an inverse relation between them. Okay? Let me tackle the next example. Alright, so I'm telling you the log base 5 of 2 is x and the log base 5 of 3 is y. And I'm asking you, what's the log base root 5 of 0.8? Well, obviously the bases are different, right? So the first thing I'm thinking about is change of base. So let me write the log base root 5 of 0.8 in function of log base 5. So I'm going to have log base 5 of the input, 0.8, and here it's going to be log base 5 of the base, root 5. Okay, now 0.8, what is 0.8? I can use 5, 2, and 3 to express 0.8. 0.8 is 8 over 10, so it is 4 over 5, right? So it is the log base 5 of 4 over 5 divided by, what's the log base 5 of root 5? Root 5 is 5 to the 1/2, so it is divided by 1/2. Okay, divided by 1/2 is the same as multiplying by 2. Okay, 2 over 1, 2. 2 times log base 5 of 4/5 is the log base 5 of 4 minus the log base 5 of 5. The log base 5 of 4 is 2 squared. Okay, so let's see what we have here. We have the log base, this is 2 squared, so I'm going to take the 2 out. 2 log base 5 of 2 minus 1. Finally, what do I have? Log base 5 of 2 is x, so this is going to be 4 log base 5 of 2, so 4x minus 2. 4x minus 2 is the expression of log base root 5 of 0.8. Okay, so please do number 9. I'm gonna do one example of graph shifting with different bases and we're gonna call it a day. So assume the point AB is on the graph of the log base 4 of 4. I want you to give me a point on the graph of, oh look, I call them all 1. What's going on here? The last one was 9, so this is 10, this is 11. Is there another one? Yep, that's 12. Sorry about that. Okay, so I'm gonna do 11 again. I have a function log base 4 of x and I'm taking a point AB on it and I want a point on the log base 2 of x squared. So the question is, how do you go from y equals log base 4 of x to y equals log base 2 of x squared? Let's do that. So the first thing you have to do is change of base, right? So let me take the log base 2 of x squared and let me write that in base 4. So this is log base 4. This is log base 4 of x squared divided by the log base 4 of 2, right? Okay, the log base 4 of x squared is 2 times the log base 4 of x divided by 2 is 4 to the 1/2, so divided by 1/2 right here again. And so it is 4 times the log base 4 of x. So I know what I need to do right here. How do I go from y equals log base 4 of x to log base 2 of x squared? The log base 2 of x squared is 4 log base 4 of x, right? And therefore AB becomes a 4b. Okay? I hope it's clear. I've just applied the change of base. Thank you for watching.